Okay, piecewise functions. Remember, this is a function made in pieces. So example 7 says the following function describes a plan for a mobile hotspot. In this plan, it costs $40 per month for 15 gigs of data, and any additional cost is 60 cents per gigabyte. The mathematical formula for this plan is C of G equals 40 if the gigabyte usage is between 0 and 15 inclusive, and then 40 plus 0.60 times G minus 15 if G is greater than 15. So here, just so we're all on the same page, this is G minus 15 because it's 60 cents for every gigabyte you use, past 15, right? So if I use 20, then you're only paying for the extra 5 gigs that you used. Hopefully that makes sense. So if I'm evaluating C of 10, I like to think of it, as two separate rules. So I just look to see, okay, so if G is equal to 10, well, is that the first rule or the second rule? Where is 10 in this ruling? Well, 10 is the first rule. So then that means we just follow the first rule. So if G equals 10, the rule tells me that it's 40. So basically we only used 10 gigabytes. We didn't go over our plan. So then we are just paying the 40 bucks that month. But if I use 45 gigabytes, so this says G equals 45. Let me change colors for a visual effect. So did y'all agree? Would you agree that 45 is greater than 15? So that means that we are using the second equation, right? Because we went 30 gigs over our allotted 15 that were given. So C of 45 is equal to 40 plus 0.60 times 45 minus 15, which we know is 40 plus 0.6 times 30, right? Because we have to pay for the extra 30 that we used. So you can grab your handy dandy calculator. So 0.6 times 30 plus 40 is 58 bucks. So this month, let me do that little money sign. So this month our bill is $58. Okay, interpret the following. Sorry, so for A, used under the given or plan amount of 15 gigs. Here we used 30 more gigs than was part of the plan. Part of the plan. There we go. Just something to that extent, right? It doesn't have to be exactly this, but as long as you understand the situation, you are good to go. All right, so moving right along with example 8, just a piecewise function here. Again, the math people back in the day did us a solid. They called it like they saw it. So this is a function made out of pieces. This has 2 pieces, right? 1, 2 pieces for sake of argument. 2, that's a 2. 2 pieces. So when I think about this, if I'm graphing, then 1 is where my number line is kind of splitting off, where I have rule 1 versus rule 2. Well, rule 1 goes all the way from negative infinity up to and includes 1. Rule 2 says anything past 1 but not including 1, we use rule 2, which just says y equals 4. So this is how it's written, right? So basically, for rule 1, it says y equals x plus 2. For rule 2, it says y equals 4, right? Just the constant 4. But like I've said before, mathematicians were inherently lazy. So like, why would I want to write more stuff when I can just write 1 stuff? Which is where this whole like brace and f of x equals symbolism comes into play, right? It's just 2 birds, 1 stone, essentially. So now, if I want to graph rule 1, then I notice that this is a linear line. Y'all remember how many points we need to graph a line is just 2, right? So let's work smarter, not harder. So since 1 is included, I know that I can have the filled in circle here at 1. So if I have, for rule 1, x equals 1, then that means that we're popping it in here. So I know I have the point 1 comma 3 because 1 plus 2 is 3. So then 1, 2, 3. So build in circle. And then notice the rule says it's everything to the left of 1. So I'm just going to willy-nilly, out of thin air, pull an arbitrary number, say, oh, I don't know, -1. So if x equals -1, we still are in rule 1 land. So -1 plus 2 is 1. So I have -1 comma 1. So here's -1, here's 2. And then I'm only going to let my arrow go to the left. Again, because remember, we have a totally different rule to the right of 1, right? Because that's what it says. We have our left piece and our right piece. We know it splits off because that's what the rule says. X is greater than or equal to 1. X is just strictly greater, excuse me, less than or equal to 1. X is greater than 1. So here at 4, well, there's nothing really to work with. Rule 2, like it says, is just y equals 4. So if x equals, say, I don't know, 2, well, then we have the point 2 comma 4 because that's what that means. So here's 2 and then here's 4. So I have the point 2 comma 4, but also I have that open circle at 1 comma 4, because again, I can be 1.0000000 a million zeros 1 and still be greater than 1, right? We just cannot be 1 exactly. And then, so then 3, 4, 5, whatever you want, also still at 4 because the rule for the second rule just says y equals 4. So whenever you're graphing a piecewise function, just kind of split it into chunks of the number line and then follow whatever rule is getting described for that specific chunk, if you would. And hopefully that makes sense.